Hey there, Pre-Calc. We're on day 2 of sketching the graph, trying to deal with what's going on here. So a lot of these things we talked about in Algebra 2, just kind of touched on. One big thing we have to talk about today is the multiplicity of a zero, and that is determined by the power. So we know if it's x minus c, that means c is going to be an answer here. And the power is going to tell us how many of that we're going to have. So I know from this one, right, I know I should get -2 is definitely going to be part of my graph, and it happens 3 times. And what that means is it's going to go through. Okay, it's not just going to touch there. But when I look at, so I'm going to put that on here, and when I put x minus 1, that's going to give me x equals +1, and this is going to go through and just touch, right? Because it's an even amount. So that means it should be a point that just touches and turns around. So let's figure out what's going on here. So altogether, I have x to the 5th power, which is odd. So that means if this is going to be a touch point and it has to go up from here, it has to go down from here because that is the end behavior of a positive x to the 5th. And it's going to go through and then it's just going to touch. Okay, now we're not going to get too far into finding those y-intercepts at this point. We just want to get the end behavior and cross those out based on the x-intercepts. Okay, so we're going to try that just a few times here. Okay, so this one, I already have all the numbers drawn out for us. So we have -5, 1, 2, 3, 4, 5, -3, 0, 2, and 4. All right, so characteristics of an odd function with zeros. Okay, so given this information, we're going to assume that it's a positive odd function. So that means we want the end behavior to be down and up. And what happens here is it goes through each and every time because I didn't list anything twice. Now, if I need you to get the absolute max and mins here, then we'll find those on a graphing calculator. The only thing we would be looking for is maybe this y-intercept. But since we already have that, right, they gave us x equals 0, then we're in good shape. Okay, so I'll just keep scrolling around the page here and we'll see which ones we have. So we'll mark some things on the graph as we go. So +3, 1, 2, 3, so it's -3. I'm going to make a point there. -2, that's 1, 2. That's going to be a touch point, so I'm going to circle that. And -1. All right, so the next thing I'll do is I'll kind of add these up. So I got 3, 4, 5, 6. So I'm talking about x to the 6th. They were all positive, so positive x to the 6th. So that means we have to go up and up. I'm reminding myself that this +2 is only a point of intersection, and then we'll come down through and through because each of these were done with an odd number. Okay, so the one that we're really looking for is that +2 to be a point that we just touch the graph but not go through. All right, so what's going on here? We got positive x to the 4th. Maybe it helps if I start saying that first. So -2 and +3. And if it's positive x to the 4th, it needs to be up and up. But here's the deal. Both of these are going to be just points that we touch the graph, okay, not actually go through based on the power. All right, so that means we're up to kind of a nice big challenge here. I found this one online. I'm like, hey, my guys can solve that. All right, so here's what we have. It's 4th degree. So again, we're going to assume positive 4th degree. I know that there is a 0 at -3. And that's the only thing I really know. The only other stuff I know is it has a maximum at 2. We don't know what it is. So that means somewhere. So I'm just going to pick a point. It has a minimum at x equals -1. So I'm going to do that as well. And if it's a 4th degree, it doesn't say positive, negative. Okay. But that means we're going to have up. And from somewhere, it has to be up again. Okay, but it doesn't really say that, right? Because I'm saying that would be a little bit of a challenge. Okay, so if this is a minimum, that means it has to do something like this. So it's going to have to go somewhere. And if this is a maximum, it's going to have a turning point again. And if this one goes to the left, so that would give me 2 answers, 1, 2, 3, And if I come back, I'll get 4. Okay, so that would give me a negative 4th degree. So it doesn't really say if I have to be positive or negative. Since these mins and maxes, they are required to be turning points. Okay, required to be turning points. So the only way to make this 4th degree is to make it negative. All right, so that's a nice little challenge problem that we have. There was one over here, and we're trying to identify the zeros. This is working a little bit backwards. So when I take a look at these, I'm looking for anything where it just touches and turns around. So that means this has to be x equals -3 and -3. I'm going to get x equals -1, and we're going to get x equals 4. So we could build it backwards, right? So I'm going to say x plus 3 has to be squared, x plus 1, because that's negative, is to the first power, and x minus 4 is also to the first power. It does have the end behavior to make that happen, right? That it is going to be up and up. So that would be a 4th degree where everything stayed positive. So we can write those zeros that way. All right, intermediate value theorem. This just means that if you are going to cross over, if you have one answer that's positive and one answer that's negative, guess what? You have to have a 0 in between there, right? So that means that if you have A and B, somewhere between A and B, there's going to be a 0 if one is negative and the other is positive. Okay, so I want to show you that. Explain why a polynomial function of an odd degree has at least one real 0. Okay, so x to the 3rd, x to the 1st, x to the 5th. So x to the 1st is just that linear function. So that means we have a slope of some sort. So it is going to, at some point, cross over that y-axis. And we look at x to the 3rd, right? So this is our basic, and then it's going to move around. And it's based on that end behavior. So whether these are positive, right? So we know the end behavior is going to be down, up in our basic terms. And let's say I took this x to the 5th and make it negative. Now it's up, down. So at some point, I still have to cross over. So that's why in our intermediate value theorem, our odd functions, our odd degrees, are always going to end up that way. So what are you looking for in the graph? Right, in the graph, we're looking for a y-intercept. In a table, like all these tables, we are looking to see if we can see that it does change from a negative to a positive while we have x's in sequence. Okay, so we know somewhere in here, there's going to be an answer. So again, I'm looking for the sequence that we have here. I went from positive to negative and negative back to positive. So I don't really care what type of function it is, but will I get a 0? Absolutely. Okay, so again, the sequence is what I have here. We're changing over. I think that's the other one that we had there. Okay, and as I look through the sequence here, I'm trying to see, I know this is going down, and it's going down, and it remains the same and goes back up. So will I get any zeros? No. Okay, well, not any real ones anyway. Okay, so just being able to see that from a table, I think is very, very helpful, so you can identify things happening later. All right, so we get a couple homeworks in here. Again, you can, as always, give those a try if you're comfortable with your multiplicity and sketching those graphs. Otherwise, we'll check in at class and you'll be able to do those when we wrap it all up.